Okay, we need to continue our discussion on k-nearest neighbor. We are almost finished. The remaining part we want to cover is how do we choose the right k-value. And as we discussed last time, if we want to choose a very large k-value, and this may slow down the model, so choosing a large k-value may not be a good idea. On the other hand, how about if we choose a very small k-value? For example, if we pick the k-value as 1. If we pick the k-value as 1 and then it is 1 nearest neighbor, well, this algorithm sounds okay. So what's the problem behind the thing if we want to pick a very small k? And then the problem is actually if we pick a very small k and then a noise, one noise sample can totally destroy your algorithm. So what do I mean here? Let me draw something. Okay, so say if this canvas is the entire possible feature space and we are only dealing with the x and y coordinates. Okay, so let me draw a few black samples here. Okay, and let me also draw a few red samples. Okay, so if we want to do a one nearest neighbor, and probably the distance boundary should be somewhere like this, right? So for example, if we have a question mark here, and then if we do one nearest neighbor, and the nearest neighbor is likely to be this black sample. So this question mark will be classified to be black. So one nearest neighbor, so far it works well. And let me give you a weird case. Say if I have a red sample here, and this red sample probably it is just a noise. And if we do a one nearest neighbor, what is going to happen? So now we are going to draw another line for the decision boundary. So another line is likely to be here. Okay, so eventually all the samples on this side of this decision boundary will be considered as red samples, and all the samples on the left side to this decision boundary will be considered as red again. Does this really make sense to you or not? Well, we don't know because this is just a fake data set. But the point is, if later we find this sample is just a noise, and here is a big problem. This noise sample all of a sudden can just change the decision boundary a lot. It claims a big portion of the possible feature space and say all the samples on the left corner will all be classified to be red. And this could be wrong. This could be very wrong in some of the cases. Okay, so this is the reason that we say picking a very small k value may not be a good choice. In this case, we are doing overfitting. Why? Because one sample adding one noise can change the model drastically, and then this is a overfitting. So let me come back and let's talk about another case. So since we say picking a very small k value may not be a good decision, so how about we just pick a large k value? Say if we have 100 samples and then we choose k to be 50. So what is going to happen there? We are picking half of the size of the data set as the k value, right? So this is definitely a large k value. So if we do that, well, the first problem should be if the k value is large and then the model will be slower. We don't want that. So that's the first problem. And what is another problem? So the other problem is now we are doing over smoothing. What do I mean? Say if we only have 100 samples in this case, and let me come back to the drawing board. Say we only have 100 samples. And then in this 100 samples, say we have 70 of the class A, and then the 30 of the class B. Okay, and we are doing 50 nearest neighbor algorithm. And do you see the problem? So when you classify with the 50 nearest neighbor, and the dataset is not that balanced, and what you will see is, well, most of the cases, the model is tend to classify the sample to be class A, because class A simply has more samples. So if you are doing a vote on 50 samples, it's very likely that the class A will win. Okay, let me make it even harder. So instead of doing 70 and 30, now if we do 80 and 20, what is going to happen? Think about that. And in this case, class A is going to mean all the votes, all the possible samples. In the worst case, well, for this 50 nearest neighbors, that will be 30A and then 20B, right? So even we have already got all the 20B samples as my nearest neighbors, this sample is still going to be classified into the class A, which is very wrong. That's ridiculous, right? So if we are doing a very large k value, and then we are doing a over smoothing, so that is the problem. We don't want to pick a very small k, we don't want to pick a very large k either. However, we have to pick the right k value so that we can have a reasonable machine learning model. Okay, and another point of the k-nearest neighbor is, well, we have to get some sense on how beautiful the dataset is. Well, in other words, how much noise do we have there in the dataset? Well, if we want to pick a super small k value, and then some noise data can totally ruin the performance of this model. And if we know the data is beautiful, or we are confident enough that the data set is beautiful, we may have some noise but not a lot. And then probably I tend to pick a small k value if possible. Even though it may not be 1, how about 5? How about 7? So this is the idea. In other case, if you know the dataset itself is very noisy, and if you want to use the word noise signal to noise ratio, and then if the signal to noise ratio is high, for example, if you are doing a speech recognition, or if you are doing a handwriting recognition, for example, those are the texts known to have very high signal noise ratio. So in this case, if we want to do the k nearest neighbor, and you may want to pick a larger k if possible. So here is another example here. Well, we are trying to classify the horse versus dog. And well, for the blue, those are the samples of dog, and for the red, they are the samples of horse. Okay, so and the x-axis is the weight, and y-axis is the height. Well, for the dogs and the horses, well, of course, their size are different. But here, if you see the boundary, you may find there are some really big dogs and there are some really small horses. So the decision boundary between the big dogs and the small horses may not be that clear. So if we are considering this sample, this sample is big enough, is heavy enough, and is tall enough. This should be a horse. And if you consider this sample should be a dog because it is small and also light in weight. But if we are considering this one in the middle, this one is right on the decision boundary. So this one could be a little bit harder for us to classify. And if you want to do a one nearest neighbor in this case, and you will see the decision boundary to be something like the first image. So even though for the lower left side there are dogs, the upper right side there are horses, and here this is a small cluster of horses inside the blue area. So this is a problem. One of the noise sample may change the classification. Do you want to have that or not? In this case, well, I don't know. Probably the decision boundary is not that clear to me. And then if you do k equals 5 and the model gets a little bit smoother, and if you do k equals 10, it is even more smooth. So if we do 50, and the decision boundary becomes just a linear boundary. So when you pick the k large enough, and then we are just do a majority voting in this case. And when you do the k equals 50, I would say it is already a over smoothing. Okay, so this is a hard question. How do we want to pick the k? We don't want to pick a very large k. We don't want to pick a very small k either. And we want to pick the k which can guarantee the better performance of the k nearest neighbor. So I'm gonna pause here and continue in the next video.